This is the final video in my series on naming ionic compounds. As I mentioned in the first video for naming simple ionic compounds, I was mainly showing you metals that only have a single ionic charge. However, when working with a metal with multiple ionic charges like iron has here, there is an extra step that we need to take. These metals with multiple charges are known as multivalent metals, and there are quite a few of them. You'll see a number of them roughly about the middle of your periodic table. When we are working with metals with multiple charges, when we name them, we have to identify which of these charges we are going to be using. All right, let's do an example. Just for convenience sake, I pulled the entries for mercury and oxygen off of the periodic table for this question. Following the same rules that we did before, we can write down part of the name for this compound. So with the entries on the side right here, we know that Hg is mercury and O is oxygen, which again, just like the previous questions, and we know that oxygen becomes oxide. The reason that this question is different from the other ones we've done, though, is because mercury is a multivalent metal. It has more than one ionic charge. Because of this, we need to specify in the name which charge we are using. This is done by writing a Roman numeral in between the two element names. Now, either it's going to be Roman numeral 1 for the 1 plus charge, or Roman numeral 2 for the 2 plus charge. But we have to figure out which one of these it is going to be. In order to do this, we have to take a look back at the original chemical formula that has been given to us, Hg2O. This tells us that we have two mercury elements and one oxygen. Again, we don't know if the mercury is a 2 plus charge or a 1 plus charge. But according to the periodic table, we do know that oxygen has a 2 minus charge to it. In order to solve this question, we are going to have to do what's called balancing the charges. What this means is that if we were to count up all the negative charges that we had in the formula, it is going to have to be exactly equal to the number of positive charges that we have in the formula. So since we have two negative charges, we're going to have to end up with two positive charges. The only way to get two positive charges is if the mercury had a positive charge to begin with. Or as shown on the periodic table, they do a 1 plus and a 1 plus there. So now we have two positive charges, which balance out the two negative charges. This means that we are working with the single charge of mercury. So in the brackets in between the two names, I'm just going to put the Roman numeral for 1. Just going back a little bit, if I were to decide to try to do 2 positive on these, then overall the positive charges would be 4 plus. That does not balance out. That will not work. So it has to be mercury 1 oxide for our final answer. For this next example, we're going to work with mercury and oxygen again, but you'll notice that this time there is a slightly different combination of these elements. The last example had 2 mercuries and 1 oxygen. This one just has 1 of each. Since we are working with the same elements, the name is also going to be pretty similar to before. So we have mercury oxide, And then in the middle, just leaving our room for the Roman numeral, because again, mercury is a multivalent metal. It has two different charges there. We need to put those brackets in the middle of the Roman numeral to show which one we are working with. Again, similar to before, I'm going to write down the individual elements. We only have one of each of these, and we know from the periodic table that oxygen has a 2- charge, giving us overall 2 negative charges. And just like before, we need to balance out those negative charges with positive charges. So whatever number we have entered in for the mercury, it needs to come out to 2 positive charges, which our only option now is that mercury must have a 2 positive charge. If there's just a single one of the mercury, it needs that 2 positive charge to balance out the 2 negatives from the single oxygen. And then in our name, because we're using the 2+ charge, we will put the Roman numeral for 2 in the brackets. So we are working with mercury 2 oxide. So note that even though we have the same elements as the previous example, the name is a little bit different, showing that it's a completely different compound. In this example, we are working with the compound Mn3N2. Again, the quick scavenger hunt through the periodic table will turn up manganese and nitrogen. So the main chemical name for this will be manganese, and nitrogen turns into nitride. And of course, we need the Roman numeral in the middle to show which of the 3 charges for manganese we are going to be using. And I will write down those elements down here. We have 3 manganeses this time, and 2 nitrogens. Nitrogen we already know has a charge of 3-, overall having a negative charge of 6. So we have to figure out which of the 3 charges we need to use for manganese to get an overall positive charge of 6. And the only one that works for the 3 manganeses is if they were to have a 2+ charge. So yeah, 2, 4, 6. So we are working with manganese 2 nitride. For this final example, we're going to combine everything that we learned over the last few videos. In this example, I've used a single element at the beginning and then a polyatomic ion, which I went over in a bit more detail in the previous video. Also at the side here, I've pulled the periodic table entry for Au as well as the entry for the polyatomic ion that we are going to be using. So again, following the rules as we did before, Au is gold. It's a multivalent metal, so we're going to have to put the Roman numeral in there. And then finally, the last part of the formula is the polyatomic ion chlorate. And as before, I am going to write out the elements / ions. We have gold, just a single one of those. And then for chlorate, it's in brackets with a 3 on the outside, which means that there are 3 copies of this. Each of them with a charge of -1, giving us an overall negative charge of 3. As for the gold, the options are either a 3+ or a 1+, but the only way we can get it to balance out the 3 negatives on the other side is if gold itself has a 3 positive charge. Therefore, the Roman numeral has to be 3. And we're working with gold 3 chlorate. And that is the final video for writing the names of ionic compounds. Next, we're going to get into writing the actual formulas from them. So we'll start off with the name and then come up with the actual formula.